Hey guys, last video for module 3. This will be lesson 3. You're going to need a calculator to do this along with me so you can understand measures of spread. Now, the first measure of spread is the range, and it's pretty simple. It's just the difference. So subtraction, it's just the difference between the highest value and the lowest value in the set. So how do we find the range? We find the highest and lowest values, and we subtract them. We find the difference. Sorry, my writing is terrible this morning. So the range, formula for the range, is equal to the highest value minus the lowest value. Pretty simple. Range is really easy. So we're going to find the data of this range. Where's the lowest value? Here, right? Where's the highest value? Here. So 37,500 minus 708 or 7,850. That's all you're doing. And I'm not asking you to do it by hand. You've got a calculator for a reason. So 37,500 minus 7,850. That's all I put in there. Subtraction problem. 29650. And that's the range. Between the lowest car and the highest car, there was a difference of $29,650. So that's the range of prices for the sold cars. Okay, this one. So, range tells us the difference between the lowest and the highest price car, okay? But it does not tell us whether the highest or lowest values are typical values or extreme, what we call outliers. So we have to find the deviation from the mean, back to our last lesson, of the data, is the difference between the value and the mean, okay? So, moving on to the next page, how do we find the deviation from the mean? We're going to do a small data set example so that it doesn't drive us nuts here. We are going to find the mean of the data set. We've been doing that today. Well, in the last lesson we've done that. It's the same day I recorded it, today. Find the amount by which each data value deviates. And that just means it's different by so much from the mean. So the deviation from the mean is the data value minus the mean. No big deal. So when the value is smaller than the mean, you're going to get a negative deviation. When the value is larger than the mean, you're going to get a positive number. Kind of makes sense, right? So if this is 5 and the mean was 10, 5 minus 10 is negative 5. So if the data value is smaller than the mean, you're going to wind up with a negative number. If the data value is 15 and the mean was 10, 15 minus 10 is positive 5. So if the data value is larger than the mean, you're going to get a positive number. So they're giving you 4 numbers here. And remember how we find the mean. We add the values together, divide by the number of them. It's just the average, right? So we've got 45 plus 63 plus 87 plus 91. And we're going to divide that by 1, 2, 3, 4 to find the mean of that data set. And once again, calculator. 45 plus 63 plus 87 plus 91 equals 286. We want to add that top first, then divide by 4 to find that our mean is 71.5. Okay, we've got the mean. Yay. Now, we're going to find the deviation for the mean for each of those numbers. So remember, I'm going to take each number, 45, 63, 87, and 91, and I'm going to subtract the mean. Minus 71.5, minus 71.5, minus 71. This is no-brainer right here because it's the same number every time. And when I do this, I'm going to find the standard deviation. So 45 minus 71.5 is negative 26.5. Okay, just keep going. You can pause this video if you need to, and I'll come back with answers, or you can just hang out, do as I do. Okay, last one. So now I have that. I have it done. This is the standard deviation for the data set, for each number in the data set. Not hard. That's the deviation for each number. Now, if I wanted to find the average deviation, I'd add those guys up and divide by 4, right? Okay, standard deviation uses the square. I'm so sorry, I lied to you. Uses the square. So standard means the whole group. What's the standard? The square of a negative number is always positive. Okay? The square deviations are averaged and the result is called the variance. Now, let's get that down. Okay? So how do we do this? We find the mean of the sample data set. Oh, we did that. What was the mean up here? 71.5. Then we find the deviation of each value from the mean. Oh, we did that. This is their deviation. Then we square each deviation. Okay? So, we're going to square that first one together. Negative 26.5 times negative 26.5. That's a square number, right? Just multiply it by itself. And we wind up with, what is that number? 702.25. So do that for each of these numbers and then come back. Okay. All I did was multiply this times itself. 15.5 times 15.5 to get those numbers. Now, the next step says to find the sum. Step 4, find the sum. So let's add those 4 guys together, okay? That's going to be 0, 0, and add a 1 up here. Then we got 7, 11, 19, 9, 1. It's 8, 10, and 3 is 13. There's the sum. Just add them together. Then, here's the kicker. We're going to divide that sum. Of the squared deviations by one less than the number of values in the data set. That amount is called the variance. That's what we're looking for. Okay? So, let's do that. Let's divide this sum by one less in the data set. We had 4 numbers in the data set, so we're going to divide 1395 divided by 3. And we get 465. All right. Final step. The final step to find the standard deviation. We take the square root of that variance. This is our variance. We'll take the square root of 465 in your calculator. That is second x squared. 465. Close that parenthesis if you want to or not. And you get 21.56. So 21.56. That's our answer for this standard deviation. So there's a little formula here. I'm going to write it, okay? We're going to find, you want to find the variance, which was this number, 465. So we're going to first, here it is, okay? We're going to take the sum of the deviations remember, these were our deviations. We did this to get that deviation. We're going to take that sum and we're going to square each of those numbers. We're going to add them together. Okay? Then we're going to come back and divide by one less than however many numbers we have. Then the final thing is to take that square root. Okay, guys, on to the last bit of this lesson. It says, it's got this big example. I'm not doing all that. You can do it if you want. Come back in a minute and I'll have an answer posted. At the end of the video, I'll post an answer for that example 3. Going to finish these lessons up right here. And we're not going to do this example 4 problem either, because you're not going to have to sketch a curve for our purposes. So, a small standard deviation indicates that the mean is a typical value in the data set. A large standard deviation indicates that the mean is not typical. Those are important, okay? Many data sets are normally distributed, and the graph of a normal distribution is a bell-shaped curve. Remember these? Looks like that on a graph. Where a normal distribution. So now that you know what a standard deviation of the mean is, you'll kind of understand this a little bit. If my numbers are 68.3% of the data, that's a 1 standard deviation. If it's 95.4%, that's 2. If it's a 99.7%, that's a 3 with a standard deviation of the mean. And guys, that's going to be the end of this lesson. There's a lot there, but remember, you're mainly answering questions. Multiple choice. You have to pull in some of these characteristics or some of this typical or not typical stuff. See you later.